All right, let's talk about approximating square roots. All right, so before we can talk about how to approximate square roots, we need to talk about the different types of numbers that there are, like the different classifications. First off, you have your natural numbers. And these are the numbers that you could physically see, right? Like 1, 2, 3, 4, 5, right? All the numbers that would not involve 0. And then later in history, we upgraded to whole numbers. This includes all the natural numbers, and it also includes 0. Now, for those of you who aren't unaware, 0 was first discovered in India. And then we upgraded again to integers. And this included all the negative numbers as well as the positive numbers. And the next part are called rational numbers. And these are the numbers that involve all the numbers in between the whole numbers. And what do I mean by that? It involves all the fractions, all the decimals. So, you would have like negative 1.5, right? Then you have negative 1/2, 0, positive 1/2, positive 1.5. And all the rational numbers include all the integers, include all the whole numbers, and include all the natural numbers. So as you can see, we have a pattern going on here, right? All the natural numbers are included in all the whole numbers. All the whole numbers are included all in the integers. All the integers are included in all the rational numbers. Now, apart from these sets of numbers, we have a separate classification that we call the irrational numbers. And I think you may have remembered me mentioning those when we talked about Pythagorean's theorem. So what are irrational numbers? Irrational numbers are numbers that are non-repeating, non-terminating decimals. They're decimals that go on and on and on forever, and they don't have any pattern to them. These are numbers that you commonly see when you take the square root of any perfect square. So numbers that you commonly see when you take the square root of a non-perfect square. Some examples of this would be square root of 2, right? If I were to punch that in on my super pink calculator here, do the square root of 2, and as you see, you have this very long decimal that does not repeat nor terminate. Now, remember I'm saying non-perfect square. The numbers that are perfect squares would be numbers like 4, numbers like 9, numbers like 16, where if you took the perfect square, you have that whole number value. And the non-perfect squares are all those other numbers like square root of 2, or square root of 3, or square root of 5. All these numbers here would give you a irrational number. Now, believe it or not, you already know of a very famous irrational number. That famous irrational number is pi. Pi is an irrational number. It is non-terming, non-repeating. And if I were to call, it's going to be 3.14. Then let me cheat a little bit here, use my calculator. 1592654, and it keeps on going on and on forever. Okay, so irrational numbers, really, you just have to know that the rules are they are non-terminating, non-repeating decimals. Okay. Now, so that covers all the real numbers, and this is what we call real numbers. So this whole thing here, these are called real numbers. So you're probably wondering, well, if these are called real numbers, what are non-real numbers, right? Well, those are called imaginary numbers. That would be the other set. And imaginary numbers, you may remember I was talking about them when we discussed the square root of negative numbers. Square root of negative numbers, you know, generally is not possible because there are no numbers times itself that equal to a negative number. But through mathematics, we came up with the imaginary number I. And I is equal to the square root of -1. So how does that work? Well, we use I mostly in more advanced mathematics to help us figure out equations where there is the square root of a negative number. I'm not going to really hit into it right now, but later on I'll be more than happy to show you how that works. Okay, so now we're going to talk about approximating square numbers, or square roots. So, the whole point of this lesson is how do we find or how do we approximate the value of a square root of a number without using a calculator? And I know it's, you know, modern times, everyone has a calculator now. You know, it's on your phone, it's everywhere, it's on the computer. There will be probably very few instances where you won't have a calculator, right? But, you know, bear with me here. Let's just go over how do we even find the value of a number that's not a perfect square and we don't have a calculator, right? So for instance, let's say I want to find the square root of, I don't know, how about 30? Square root of 30, right? Now, here's the thing about finding the square root of 30. I can't tell you what that is off the top of my head, but I do know what the square root of 25 is, and it's less than the square root of 30. And I do know what the square root of 36 is, and it's greater than the square root of 30. And the square root of 25 we know is 5. The square root of 36 is 6. So that means that the square root of 30 is going to be in between the numbers 5 and 6. Now, we have to narrow it down, all right? 30, the number 30 seems closer to 25 than 36, right? Because it's 6 away from 36, but 5 away from 25. So I feel like it's going to be closer or less than 5.5 than greater than 5.5, okay? So again, we know that the square root of 30 is in between 5 and 6, and it's going to be 5 point something. That's what the number is going to be. So we're going to go ahead and figure that out, right? So you got 5.1, 5.2, 5.3, 5.4, 5.5, right? And let's say we want to square each number. And you know, this is actually pretty handy because sometimes we end up with basic calculators that don't have a square root function, and they do have multiplication and division though, right? So this type of method is really helpful in those kinds of situations. Now, let's go ahead and find out what is 5.1 to the power of 2. Well, if I multiply with itself, I end up with 26.01, which is not very close to 30. You know, I need a number that's much closer than that. So we'll try 5.2 multiplied with itself, and we get 27.04. Okay, we're getting closer, but again, it's not 30. So we go ahead and try 5.3 to the power of 2, and we get 28.09. And this is pretty much a guessing check kind of thing, right? We're going to keep trying and trying until we get a number that's pretty much right where we need it. So 5.4 to the power of 2, and we get 29.16. And now, this is when things get exciting. Wow, we're getting really close to that answer, right? Then we do 5.5 to the power of 2, and we get 30.25. So, of the 5 numbers that we were using, we find that 5.5 is the closest that we can get to 30. It's 30.25. We could say it could be 5.4, but 29.16 is farther away from 30 than 30.25. So we'll say that square root of 30 is approximately, and see these wavy lines here? We use these wavy lines to say that it's approximately, meaning it's not exactly equal to that, but it's very close to it. And we're going to say that it's approximately 5.5. And that is how we approximate square roots. So we've covered all the different classes of numbers. We talked about whole numbers, natural numbers, integers, rational, irrational, real, imaginary numbers. And we've talked about how we can approximate the square root of a number without using a calculator by using a guessing check method or brute force method. Okay, see you next time.